Hello guys, welcome to the physics examination preparation series. In this presentation, we will be interacting with question 2 of our paper, which is based on Newton's second law. So how does it look like? It looks like this. All right, so the context is such that we're given two crates, crate P and Q, and there's a force F acting at crate P, which is acting at an angle theta, and that theta will need to determine it later on in the questions. All right, 2.1 is just asking us to state Newton's second law in words, okay? And this is easy 2 marks. You should always get these marks, guys. There's no reason for you not to get them, okay? But the keywords that I've underlined here in red are important to be seen as part of your statement, okay? Net force, you can't just say force, okay? That is not specific. And also you must talk about the direct proportionality of acceleration and the net force that acts on the object, as well as the inverse proportionality of the acceleration and the mass of the object. And if you do that, you'll definitely get full marks. All right. So what can we then expect? The subsequent questions will be applications of this law, and that is how a physics paper is structured, guys. If you know the definition, you know the mathematical equation or equations, then you are on the right track and the right channel of thinking in that particular question. So our frame of mind in question 2, we're dealing with Newton's second law, free body diagrams, and we need to produce some mathematical equations to solve the problems that are going to follow this guy right here. Okay, let us go to 2.2. Let's remind ourselves, how does it look like? Right, so 2.2 is asking us to draw a free body diagram for crate P. Now, you need to free the body from the system and ensure that you only focus on that body called P in this case. And we usually replace the body with a dot or with a block. All right, so in this case, I'm going to use a dot for crate P. And you want to look around crate P and see if there are any visible attachments to the body. What is visible that is attached to crate P is tension, right? Crate P is pulled to the right by block or crate Q, right? That is your first vector there, or the first force that we indicate in our free body diagram. Good, it has mass, and therefore it will definitely have some weight, okay? If you like to use Fg in terms of W, it's up to you, okay? Same difference. And because it's on a flat horizontal surface, you'll definitely have a normal force going up equivalent to the weight, okay? And we are told that there is frictional force, right? So this friction definitely in the opposite direction of motion there, okay? And it's a 4-mark question, so definitely we need to see 4 forces for you to get the full 4 marks, okay? So that is the free body diagram of crate P, okay? Good stuff. Let us go to 2.3. Right, so there are 2 parts to 2.3. 2.3.1 is asking us to calculate the magnitude of the tension, okay? What do we know? The motion is happening horizontally, so only horizontal forces will contribute to what? The net force here. So F net is equal to MA. So we have T minus the frictional force is equal to MA. Those are the 2 forces giving us the net force acting on crate P. All right, we want T. We are told that the frictional force acting on crate P is 1.8. And we have the mass of crate P to be 1.25 kilograms, and the system it is accelerating at 0.1 meters per second squared to the right. Okay, so clearly you can see that I chose motion to the right as positive and forces going to the left as negative. So in other words, you need to obviously ensure that you work properly in terms of your signs for your vector quantities. Okay, good. So if you do this, you will get T is equal to what? 1.93 newtons. Okay, just multiply and transpose the negative 1.8. So this takes care of question 2.3. Right, so 2.3.2, we may need to draw the free body diagram for crate Q here. We're not asked to do that, just as a frame of reference. Okay, and here we have the tension 1.93. Also, we have the frictional force. Okay, frictional force, we are told that it is 2.2 newtons for crate Q. Okay, I'm not going to draw in the normal force and the weight, okay, or the gravitational force. Those are there, we don't need them because the motion is happening horizontally, and again, this is just a sketch or a frame of reference. So what are the forces that will contribute to the motion? This two horizontal forces going to the left, but also what? The x component of this horizontal, this diagonal force that is acting at an angle of theta to the horizontal, right? So this guy, Fy, we don't need because there's no vertical motion happening there. Okay, so what do we take? We take only these three forces. Okay, motion to the right is positive, motion to the left is negative. Okay, so F net is equal to MA. So we have Fx minus T minus frictional force is equal to MA. What is the S component? It will be what? 7.5 cos theta, right? Minus the tension, we got it from here, 1.93 minus the frictional force is 2.2 equal to the mass of crate Q is 2 kilograms. The system is accelerating at 0.1 meters per second squared to the right. Okay, so if you do this, you clean up, you get the theta is equal to 54.78, guys. 54.78. Good. So this takes care of question 2 that was based on Newton's second law. Straightforward, clean, easy marks to get. All right. Let us now go to question 3, which will be in the next video, and I definitely hope to see you there. And let's continue learning. Let us continue excelling. All right. So let's go for it. See you there.